Okay, good evening and a warm welcome to this wonderful webinar. To be precise, the ninth webinar in this series of webinars being conducted by the Tech Savvy Group and strongly supported by Prihan Mumbai Licensed Plumbers Association. Last session in which we spoke about water conservation through automation, there where Mr. Adnan Leri had strongly suggested that we also talk about recycling of water. So today we have a wonderful expert with us, Mr. Purshottam Yemul. He's a wonderful friend. He's my go-to person whenever I have anything to talk about, whenever I need anything to know about wastewater. Mr. Purshottam is the man I talk to all the time. So, just giving a brief introduction about him, Mr. Purshottam, he did his diploma in mechanical engineering from Government Polytechnic Jalna. He holds a bachelor's degree in mechanical engineering from MIT Aurangabad. He's a very result-oriented professional with over 20 years of experience in the field of water and wastewater treatment solutions. So, if if you really need to think about recycling or any wastewater treatment or water treatment, he's the right person. He's presently the proprietor of Messrs. Pratham Envirotech Solutions. He has expertise in designing and executing turnkey projects of water and wastewater treatment plants. He has a full-fledged team for the operation and maintenance of STPs, ETPs, and WTP systems. He is working with reputed builders, corporates, and industries, and has executed more than 200 plants through the country. That's Mr. Purushottam. Before I hand it over to him, as usual, you'll most of the ones who are regular here know that this is going to be recorded and put up on YouTube. After this session, we will be having a question and answer session as well, where you can either raise your hand option by clicking on the button, or in case that feature is not available to you, you can always turn on your video and your question will be taken one by one. Over to you, Mr. Purushottam. All the best.
Thank you so much, sir. Yes, sir?
Yeah, please go ahead.
Thank you so much, everybody, especially all the members, BMLPA, and especially Deepak sir, Chintan sir, who are always supportive to me. And it's my privilege that I'm here to present this wastewater treatment plant in front of you, all the dignitaries. You are all expert in your field. Still, I try to explain my point of view. Everybody can see this?
No, the screen is not yet seen, but I think it should come up anytime.
One small request, I would request all the participants to keep your videos off, please, for the time being.
Yeah, very logical request.
It started, sir?
Just hit the screen share. Right now, I can't see anything.
One second. My mistake.
Yes, perfect.
That's on. The screen is on now.
So friends, we are starting now. We're talking about wastewater treatment management today. All of you can hear me?
Yes, sir. Yes, Purshottam.
Yeah, loud and clear.
See, nowadays, the wastewater management and treatment is a very critical and very essential thing. As you know, water scarcity, a lot of government restrictions. So it is very essential now to go through this and to understand this. you see these figures, we have population of almost 120 crores approximately, 1.28 crores in Mumbai, out of which around we generate 2898 MLD water, wastewater per day. It is approximately 225 liters per head is the norm. And in India, totally we are generating 33,212 MLD sewage as per the data available in 2006. Whereas it is very surprising that country has installed a capacity of only 6190 MLD treatment plants. So we are treating only approximately 20% of sewage which we are generating all over the country. These are type of wastewater, domestic wastewater, you can say. First is black water. Black water is nothing but WC water, you can say. Water which comes from wastewater comes from the WCs. Then grey water. Grey water is the water from the bathrooms, kitchens, and washing machine. Basically utilities. Then comes yellow water, urinal from urinals. Then brown water, which is black water without urine or yellow water. In STP or the treatment of wastewater, we're treating all these things: black water, grey water, yellow water, and brown water, everything in STP commonly. Whereas as per NINA authority, new authority, Panvel area, which is the new authority, they are as per their restrictions, we have to treat black water and grey water separately. Whereas in BMC and other areas, all this water is treated in the same treatment plant, sewage treatment plant. See, levels of domestic wastewater. These are the parameters: BOD, COD, organic nitrogen, ammonical nitrogen, total nitrogen, phosphorus, total solids, and suspended solids. If you see these figures, these strong, medium, and weak. These are figures: strong, medium, and weak. Whereas to design the plant, we always consider some ballpark figure, like the two important figures are BOD and COD to design the STP. We always consider BOD in the range of 300 ppm and COD in the range of 600 to 700 ppm to design the plant as an average value of strong, medium, and weak. And you must have been aware of these suspended solids and all. So basically, we are putting these treatment plants to treat and to reduce all these constituents. Now, what is COD and BOD? Why we have taken only two parameters? The reason is these are the only two parameters which are very essential to treat. If you treat COD and BOD, everything can be taken care easily and automatically. First is COD. COD is chemical oxygen demand. It is the measurement of chemical in the water that can be oxidized. See, what we are doing in STPs or treatment of the wastewater is we are treating this with the help of bacteria, growth of the bacteria. That is nothing but oxidization. So, COD is total chemical present in the water which can be oxidized, which we are oxidizing in the STPs. Whereas BOD is a biological oxygen demand, which is supposed to measure the amount of food that bacteria can oxidize. This is the real BOD which we oxidize in the aeration tanks or MBBR tanks with the help of the aeration and giving the proper oxygen to the bacteria. As far as measurement is concerned, COD can be measured with very simple method in any laboratory, which can be measured in the 2 hours only. Whereas BOD will take 3 to 5 days. There are two types of BOD measurement is there. BOD 3 days, BOD 5 days. But normally to get the exact figure, always go for the BOD 5 days. So that is the reason when we give any sample to any laboratory, it takes minimum 5 days to get the results, because BOD itself will take a 5 days minimum for measurement. Now, wastewater problems in India. Our country is having full of problems all the time. Speaking of Mumbai alone, we have almost 77 lakh 30,187 people who have adequate sanitary facility. These people who live in slums and generates around 1739 MLD of wastewater per day. Again, there is a 225 liters per day per person is the norm. The disposal of this untreated domestic water is a hurricane task. Improper disposal of usually leads to a waterborne disease. All these slums don't have a proper drainage system, so there is no treatment. All this water is going to nalas and river, and ultimately that is going to contaminate us, and it creates a lot of diseases. You can see the pictures. This is a river, nala, India lacks of infrastructure. As per CPCB estimation in 2006, India generates 33,212 MLD water, sewage per day. But we installed only 6190 MLD sewage treatment plants across the country. So we are treating only 20% of the wastewater which is generating. 80% wastewater generating is, again, we are going through these nalas and rivers and all. Even this treatment capacity is confined to a bigger and more powerful towns of the nation. Like in New Bombay and Bombay, in Bombay especially, where a lot of STP plants came up. Because the New Bombay corporations and big corporations have a lot of funds. So they can put big STPs, they can lay the bigger pipelines, combined pipelines, and take it to the sewage treatment, common sewage treatment plants. Whereas in smaller cities, they don't have funds and they don't have proper infrastructure. So again, there is also a big problem. Again, this is one more problem, big problem. Unavailability of correct data. No one really knows how much sewage is generated. It's very surprising. After 1947, after freedom, after 75, 80 years, we don't have a perfect data whether we can design the system. It is well known that 80% of all the water consumed by a city is released as wastewater, untreated. So it should be easy to calculate how much wastewater generates by simply looking at its water consumption. Unfortunately, that doesn't work in our case. The government estimates 70 to 80% sewage generation of the total water supplied as you can say thumb rule. Example, BMC only provide 90 liters water per person for domestic purpose, and remaining water you are forced to further arrange on your own. Probably wouldn't have a control on that. It's a case study. According to Delhi Jal Board, the city generates 2947.8 MLD sewage in 2005. This was based on the quantum of DJP supplied. But when CPC measured wastewater flowing through Yamuna, it found the discharge is 3684 MLD, which is 700 MLD higher. So both these Delhi Jal Board and CPCB both are government firms. They don't have proper data, and data is also not matching to each other. The difference is 700 MLD. It's very high figure. deteriorating infrastructure. The problem is further complicated when we realize that installed treatment facilities like septic tanks, STV do not actually end up in treating the wastewater. This is a common problem now. In a study conducted along with the BMC, it was found that majority of the septic tanks used were either not working well or just functioning as the sewage collection tanks. The reason is a septic tank which needs to be needs to be cleaned after every 6 months or 1 year. Nobody bothers about that. So what happens? It will be treated as a collection tank, and after overflow, we'll pump it out. And there is a lot of smell and all this uh, sewage flowing through roads and all those things. Problem number 3. Majority of the toilet blocks use septic tanks due to unavailability of street sewer in the vicinity of the slums. Correct? By this, I don't mean that say the septic tank does not work. In fact, septic tanks are very good option in the absence of municipal street sewers, but only to the condition that they were constructed in a proper manner and used for the guideline laid down for them. In slums and everywhere, septic tanks are there, but they are not properly either designed or maintained. That is again creating a lot of problems in the like health diseases and environmental problems. STPs. Usually STPs are located where land is available. As a result, sewage has to be transported long distances from the source of generation and collection to the treatment site through conveyance system. In short, electricity is used to run the pumps for this. Also, most cities like a functional drainage system to convey the waste. It is equally important to note that longer the distance, more the cost of conveyance. See, the infrastructure available in the STPs are first is the laying of the pipeline, then operating the system, to spend on the operation of the system like electricity, manpower, other things, and to maintain it for longer time. And again, after a particular time, you have to again repair it or refurbish it. That is also a lack of infrastructure. You can easily understand with this arithmetic. Sewage generated across India is 33,212 MLD. Capacity to treat available is 6190 MLD. Actually treatable 4469 MLD, 72%. So 28,743 MLD is not treated. So annual cost of treatment of 6190 MLD sewage is approximately 135 to 677 crores annually. So capital cost required to build the STP for remaining untreated water, that is 27,022 MLD, is 7,566 crore. Considering 28 lakhs per MLD is a approximate capital cost. See, 7,560 MLD crore rupees is a big figure. And to arrange these funds and to arrange the funds for the annual cost of treatment, you can see this is 700 crores. It is very difficult to maintain these systems, centralized systems. So what we always recommend is to go for the decentralized systems. Decentralized systems can be easily operated and maintained because it is operated by society or corporates or industries. So we're coming up to the different systems available for the treatment of the sewage. As far as decentralized systems are concerned, first is septic tank. Septic tank, is commonly known thing for everybody. Most commonly used wastewater treatment for low-cost housing applications, since most septic tanks can cater population up to 300 people. Often confused with the cesspools, works on a principle of anaerobic microorganism digestion. See, this is septic tank. You have seen that. First, sewage comes from this by gravity. There are baffles, two baffles, passes through baffles. So first, in first phase, the sewage sludge sediments here in the first phase, and semi-clear water flows through to the sediment. This is a common septic tank figure. So now we have to remove this sedimentation or sludge on a regular basis, like 6 months, 1 year, or 2 years, depending on the load. And finally, it goes to a soak pit here. This is again a big problem. If we don't have a proper soil strata which can soak this sewage, then it doesn't soak the sewage and it come back and this septic tank overflows. So while designing the system, to take proper care of the, first of all, the proper design of the system, then what is the soil strata, the location of the septic tank, and the removal of the sedimentation or sludge on regular basis. Otherwise, it doesn't work properly. That is the reason if you can see lot of septic tanks, you can see it smells. The reason is it doesn't maintain, and it is an anaerobic treatment. If it doesn't done properly, it gives a foul smell due to anaerobic gases. Septic tank. The advantages are, this is a very age-old established technology. Underground, so invisible, not visible. Pathogens removal is very good. No power supply required. The most important is the last point. No power supply required. It's very good and working very nicely. The reason is it doesn't have any operating costs, especially in the slums and low cost areas. It's very effective because they cannot afford this price to these operators or power supply and chemicals and those things. Negatives. Treatment is only primary. The reason is if you are supplying a BOD 300 at the inlet of septic tank, at the outlet you will get approximately 150 BOD. Whereas in other STPs like MBPR and other aeration systems, inlet is 300 and outlet is less than 10 ppm, which can be used for the flushing. Whereas septic tank outlet we cannot use as a flushing or any other purpose because it is only primary treatment. It must be desludged on fixed intervals depending on the design. It is very important. Otherwise, it creates a lot of smell and overflow. The process is entirely anaerobic and hence eliminate a foul odor. This is anaerobic system. Anaerobic. All the bacteria are anaerobic bacteria. Treatment is completely anaerobic. That is the reason there are chances of foul smell if it doesn't maintain it properly. Then comes to a very old conventional system called as the DVATs. The DVATs is based on different natural treatment technologies put together in different combination according to the need. I'll explain. See, in DVATs, first is primary treatment. Is used for the screening and sedimentation process, in which the liquid part is separated from the solid matter and septic is used for this phase. In secondary treatment, biological and natural chemical processes are used to digest and remove most of the organic matter. A device called as the anaerobic baffled tank reactor. tertiary treatment. It is a natural system, so it doesn't have a sand filter and carbon filter. There are natural gravel filters acts through a combination of different layers of sand and semi-clay water passing it through, and there are pebbles, granite, stones, and passing through this water gets cleared, and this is the all video. You can easily understand what is how DBAT system works.
The first stage is the settled tank. Here the contaminants are retained by flotation and sedimentation, which happens through natural separation of heavy particles. The heavy particles sink down and lighter particles float. Second stage is baffled tank reactor. In these tanks, an anaerobic treatment takes place based on metabolism of specialized bacteria, which will transform the organic pollutant into bacterial matter. During this process, the fresh effluent is mixed with an active sludge blanket deposit of microorganisms occurring naturally at the bottom of the chambers. During this progression, the accumulated sludge is gradually reduced. At this stage, average BOD reduction is about 75%.
What are the advantages of DBATs? High treatment efficiency, customizable as per the treatment requirement, beautiful landscaping possible. This is very important. No waste water above ground, no nuisance of water. Basically, these DBAT systems are very good and useful where the lot of land is available. These are the negatives. High space requirement, 30 square meter per cubic meter of daily flow. 30 square meter for 1 meter cube of daily flow. Costly if desired gravel not available, because since it's a gravity filter, needs a very high quantity of media. Intensive maintenance and supervision during first 2 years. See, another technology, which is a natural and very good technology, is Phytoretechnologies. These are the components of the Phytoretechnologies. These are the processes: sedimentation, bacterial action, filtration, absorption, precipitation, decomposition, nutrient uptake, vegetation system. This phytorid wetland comprises of primary settling cell for the purpose of anaerobic pretreatment for suspended solids, secondary advanced filter cell that supports a permutation of different sizes of stones and gravels wherein anaerobic digestion occurs. Last is tertiary biological wetland cell made up of different layers of life supporting media such as those used in FAFC and planted with aquatic flora such as Typha, Scarpus, Cyprus, Patentra and Pagmatis. You can go through this video so you can understand better what is phytoread system. This is primary cell. Secondary filter cell. Tertiary biological wetland cell. These are some plant they planted above these gravels. I told you the advantage is high treatment efficiency again. No mechanical parts, complete, no bumping at all. Everything is natural. So energy efficient. Beautiful landscaping possible. No blockage by sewage solids. Negative point is, or disadvantage you can say, high space requirement. Again, it's a natural system, so and there is no mechanical pumping and all, so you need a more space. Not ideal for the urban scenario, especially the areas like Bombay and metropolitan cities. High greenhouse gas, methane emission. We have to keep a close watch on the this methane gas emission, and we have to control it. Otherwise, it can create a problem. Intensive maintenance required. Constant supervision required. Then comes soil biotechnology. You can say SBT. The soil biotechnology system consists of a impervious containment, typically 1 to 1.5 millimeter below ground. Organic wastewater is processed in an ecosystem consisting of soil-like media. This is media. Bacterial cultures, geographic earthworms, natural mineral additives, and select plants. Natural mineral additives are those used as a process regulator in order to achieve desired treated water quality, which is nothing but you can say cultures. We are normally say in normal language cultures. Purification takes place by adsorption, filtration, and biological reaction. The process operates in an aerobic mode, not anaerobic, thus eliminating possibility of foul smell. The wastewater processing area is thus developed into a green belt, which easily integrates into any existing landscape. See, these are the processes by which you can treat this. These are different layers in this SBT technology. Water passes through these layers. See, we are pumping raw sewage from here. These are different layers. By passing through these layers, treated water come to this final treated water storage tank. This composition of patented soil biotechnology first is plantation as indicators of plant's health. Additives, that is high performance enzymes, we are adding it. Cultures, microorganisms, media, specific mineral, rock, stone, solids. So all this wastewater passes through these 4 layers and then comes to treated water. This is the common schematic flow diagram of the soil biotechnology. You can see this.
In keeping with the theme of decentralized development, a new wastewater treatment technology is on the horizon. One that may hold some of the answers. Soil biotechnology sewage treatment plant is an indigenous wastewater treatment process that uses nature's processes to purify water. Professor H.S. Shankar and his associates from the Chemical Engineering Department at the Indian Institute of Technology, Bombay, developed this technology. The institute has also received a patent for this technology from both the US and the Indian patent offices. Here, nature's fundamental actions of respiration, photosynthesis, and mineral weathering purify the water. The filtering equipment of a soil biotechnology plant is called a bioreactor. The construction involves digging of a trapezoidal trench which is reinforced with riprap. A layer of rubble is added, above which a proprietary culture of soil, earthworms, and bacteria are added and covered by another layer of rubble. Over this, rows of plants are laid, in between which rows of pipes are laid. The sewage water is sprayed through the pipes and is filtered as it trickles down this bed.
Positives of advantages of the Spd Technology. High treatment efficiency, again, low carbon footprint as compared to other technologies like DVATs. Low energy consumption since there is no pumping, it's completely gravity flow. Beautiful landscaping possible as you see in video. And disadvantages are open system, hence some order may be possible. Distribution lines can get clogged, which need to be cleaned regularly. Regular maintenance required. Both flora and fauna of the system need regular supervision. This is one more technology, SIBF, solid immobilized biofilter, is the nature's way of handling wastewater and based on ecological engineering. SRBF houses the ecosystem developed for the specific requirement of wastewater treatment. The wastewater is produced by this ecosystem, which converts the impurities trapped in the biofilters into stable components, followed by a polishing tertiary treatment. The final treated water meets the pollution control norms and can be used for the gardening, irrigation, construction, and toilet flushing purpose. This is the complete flow diagram of this system. So you can see here for primary treatment, you can say screening and all. We're pumping this sewage to biofilters, biofilter 1, then biofilter 2. This is the tertiary treatment. This is collection tank, biofilter 1, the pumping, biofilter 2, and then this is alarm tank for coagulation, and this is a tertiary treatment of sand filter and carbon filter. The advantages of SRBF technology is again a good treatment efficiency, low carbon footprint, low energy consumption, beautiful flowering landscape possible. And disadvantages are distribution lines can get clogged, which need to be cleaned regularly, regular supervision required, gardening skills required for maintenance, additional filtration and polishing required. As we have provided sand and carbon filter there, as well as disinfection at the tertiary treatment. Now we are coming to systems which are majorly used in the decentralized system, especially in the city like Bombay and major metropolitan cities, where this land is the biggest problem. We need we have always provided the smallest area possible for the STPs. We don't have a space for even a small car also. So land cost is very high. That is the reason all these decentralized systems are very, very important, especially for the region of Bombay and the metropolitan cities. The first technology is membrane bioreactor, popularly known as MBR technology. This MBR is designed to produce high quality treated water from the wastewater. It is available in standard and customized modules to treat domestic sewage and industrial effluent. Basically, this is the membrane technology. If the treated water available through this MBR is a crystal clear water as good as a drinking water, because it passes through a same permeable membranes, which are very costly. You can see this video. There is any water. This is basically Singapore-based video. Singapore is the total Singapore is operating on the any water, which is a completely recycled water from the sewage. See, first in MBR system there is a fiber filter before going to the membrane. This net filter is nothing but a membrane media, semi-permeable membrane. This is UV treatment for disinfection at the final stage.
Purshottamji, I'd just like to add one thing here. Sorry to interrupt you. I visited one of these new water centers in Singapore, and it's an amazing state-of-the-art facility, the new water plants in Singapore. So, yeah, what you've shown is exactly the way. Of course, it's in a very different comical way, but yeah, it's amazing process basically which has been shown here.
Chintan, you can add the Sarah's choice about water in Singapore, please.
Yeah, actually, regarding about this new water, also one more thing we had is I was there for the World Plumbing Council scholarship, and my twin daughters were very young then. One of the daughters is very finicky about the taste of food and water, so she was the one who did not like any water, any kind of bottled water which we would give her, be it Dasani, Evian, or whichever brand we could come up with. She was not liking that. I had a few bottles because new water is also produced as bottled water. They give you bottled water kind of thing. And my daughter took to new water so much that she liked it better than any other bottled brand. So you can think the quality of treatment this water has. So yeah, please, Purushottamji, continue.
See, advantages of this low Mbps technology, low energy consumption, compact system, of course. The reason is aeration tanks is very small. You need only membranes to treat the system, and area required for the system is almost 50% of what we required for the Mbps system or normal SBR system. No chemical requirement, single packed automatic unit, minimum civil work and pre-treatment, consistent water quality. This is really a very good system because the water you get treated water is as good as drinking water. But disadvantages of the system: expensive membranes modules need replacement after 10 years or so on. This is a major drawback of the system, especially in our country if we want to use it on regular basis on the large scale. The membranes are imported, very costly. You need to replace the membrane after every, say, as per my experience, it is 5 to 6 years, which is a very big cost, which cost cannot be afforded by the societies or not even by some profit also. Then membrane fouling may need immediate replacement. And last and very critical, may require special handling, treatment and disposal. Because when we are operating other technologies like MBBR and all, or SAP system, we don't need a very skilled operator or persons to manage the system. Even a person of 10th or 12th educated with a good experience in this field, he can maintain it easily. Whereas in MBR technology, you need a proper skilled person who is having a thorough knowledge of the system and thorough knowledge of to solve the system. And it is a PLC based automated system. You should have a knowledge of that system also. And if required, you have to call the person to repair that. That is a big cost. Manpower cost, skilled manpower plus repair and maintenance and membrane replacement. That is the reason this MBR is out of our reach for the normal societies and middles. Now come the most popular and system nowadays. 95% or 90, you can say 98% plants where we're putting in the Bombay is based on the MBBR system. This moving bed bioreactor or fluidized aerobic bioreactor is based on the concept of suspended growth. See, initially, when in the olden days, you can see a lot of treatment plants with the open aeration tank and big surface aerators and big clarifiers and all those things. But by the time in last say 30, 40 or 50 years, space constraint is the biggest problem. So what we have done is in MBBR technology, it is nothing but an old activated sludge process only. But by adding some media, which it can be used for the suspended growth in the aeration tank and some settling tank, we have reduced the volume of the tank to almost 50%. That, and by that way, we are saving the space required for the STP plant. But basic principle is the same, activated sludge process. But we added a media which is called as the MBBR media, which will act as a suspended growth in the aeration tank. This is collection tank where sewage is coming, raw sewage. From collection tank, we're pumping the sewage to a MBBR tank, where at the bottom we're putting the air diffusers to give the diffuse aeration, so that we can get a more oxygen for bacteria to grow. Right, one second. This is the media. This is the media which we are using to save the surface, to increase the surface area of the aeration tank. What the media is? This is a media, round in shape. You can see this surface area, this attached growth system. So this media is covered with a lot of bacteria and gives more surface area for bacteria to grow. After aeration or by MBBR tank, it goes through a settling tank where all this sludge settles here and semi-clear water goes to for further tertiary treatment. MBBR system, the advantages: no moving parts, wide treatment range, can be added in modules, elimination of skilled monitoring, totally closed system for small capacities, no sludge recycling required. In hello, are you
Yeah,
getting?
Purshottam, we can hear you. Yeah, we can hear you.
So Mbps system, as I said you, is the most popular system. The only reason is it needs a less space, less capital cost, and less operating cost, because you don't need a skilled manpower there, more skilled manpower, and don't need a high cost of membrane replacement and all those things. That is the reason nowadays 95% plants are of MBBR based plants. The disadvantages are height restriction. The minimum height required is about 5 meters. May increase civil and structural work if installation planned in basement. May require consistent inflow of sewage or wastewater. The last statement is we need at least 25 to 30% of the design capacity to operate the system to maintain the biological system. Otherwise, the system doesn't work because it doesn't get food on regular basis for bacteria to grow. Some other options are SAF system. It is the same system as of a MBBR system. The only difference is the media. In MBBR system, media is round and floating. It's a floating media. Whereas in submerged SAF system, the media is fixed and submerged in the water. Again, low initial capital cost advantage. Needs a smaller settling tank due to higher settling rate of sludge, lower energy consumption. Disadvantages require skill monitoring and choking of media, which is very important, because if you see the media shape and figure, this is basically sheets, the PVC sheets stick together. The height of the one block, then block made, one height of one block is 700 millimeters, 1.2 meter by 700 millimeters. It is submerged in the water. If at all you want to repair the diffuse aeration at the bottom or diffuser at the bottom of the aeration tank, you have to remove complete media, and which is very difficult because it's a block and filled with a lot of sludge. So it's a big task to remove that to do the maintenance. That is the biggest drawback of the system. That is the reason everybody is now going for the MBBR in place of the SAF system, because in MBBR the media is floating, so you can easily do the maintenance for the aeration system. Whereas in this case, it's a big task to remove that and again put it back. Then comes to a sequential batch reactor. If you see all the nowadays all the municipal corporation plants, all over in Maharashtra, maybe in India also, 99% plants are based on the SBR system. If you have visited any new plants installed in the New Bombay area, like Vashi, Nerul, Belapur, all are based on SBR technologies. SBR is sequential batch reactor. It is an activated step process. SBR reactor treat wastewater such as sewage or output from anaerobic digesters or mechanical biological systems. Again, there is a diffusers at the bottom to give the oxygen to the bacteria. If you go through this system, there are 5 stages of the treatment: fill, react, settle, decant, and idle. One cycle is of 6 hours. If you fill the water in the first cycle for 2 hours, and it takes 6 hours for the first cycle, that is the reason there are always 2 SBR tanks, so that when one tank is going, fill is going on, other tank will decant. You can see here, This is pre-react chamber. It's nothing but a collection tank. And this is a SBR tank. There are diffusers at the bottom. These are mixers, pumps, and sludge removal pumps. This is a decanting system. Decanting system will remove the clear water outside and remove the sludge also. So start the filling. Fill anaerobic phase. Then we only aeration phase for say 1 or 2 hours. Next phase, aeration is off and put it keep it idle for the settling for say another 1 to 1.5 hours. You can see sludge is settling down. Then the decanting phase. So the clear water will go to the other tank, same clear water, and sludge can be removed. Now, in the last phase, we come to the government endorses and also mandates. Why STP is compulsory nowadays and everybody's after STPs, and what are the norms for treatment of the sewage treatment plants now? There are, first of all, first case is when the project comes under the MOEF, or you can say approval. A project where the norm is if the built up area is more than 20,000 square meter, you have to go for the MOF approval. And in the MOF approval, the sewage treatment plant is compulsory. So we have to put that. That is the first. Second thing, if it is a high-rise building is above 70 meters, there is a height where the building is 70 meters above, then again you have to go for the sewage treatment plant as per the high-rise committee mandate. Third thing is, if you are going for any certification from the green certifications, a lot of green certifications are there. Again, there is a STP is compulsory. You have to go put a STP plant to get that green to satisfy the green norms. And last is where there is no sewer lines available. Like in Bombay, a lot of places are there where there is no sewer line, municipal sewer lines. So they cannot throw the sewage directly outside, which is not allowed. So again, in that case also, we have to go for the sewage treatment plants to treat the plant. The conclusion. The conclusion, in my opinion, is you have to go for the treatment system, decentralized sewage treatment system, either MBBR or SBR, depending on the space available, depending on your capital cost available and manpower available. To save the pollution to the system, as well as to pollute the your rivers so that it will not create your any diseases, keep you your health good, as well as to conserve the environment. And lastly, to satisfy the government norms, to follow the norms, which is very essential.
Thank you very much, Purshottam ji. Very well presented. I think you'll have to turn sharing off because I see myself again.
One second.
So yeah, indeed a very wonderful presentation, very knowledgeable, very insightful. We now will open this session for question and answer. So whosoever have any questions, please raise your hand option.
I have
or
first
turn
question.
video.
I
Yeah,
have
I
first
think
question
you have the
and
first.
few corrections to be made. Mr. Purshottam, first and foremost thing, the septic tank which works on anaerobic bacteria needs to have the T's on inlet and outlet to prevent scum flowing away. Because if the scum goes away, then it's quite likely that the oxygen may enter the fluid or whatever you say, and anaerobic bacterial function will not take place. Am I right, sir?
You're right.
Okay. Now, second thing is in some of the area, some of the specifications they have given, they have told that the minimum liquid depth should be 1.2 meters for anaerobic bacteria to thrive and do its work.
Not
Yes,
one.
that is as per the CPHEO manual.
It is in 1.5.
It is 1.5. Okay.
Yeah.
Okay. And one more thing. Now, these our DVAT and SBD treated water. I didn't see any it's treated water in domestic or maybe flushing or gardening purposes. So what's the state?
It can be used, but it can be easily used if you properly maintain the system. But the problem is that these systems are very difficult to maintain and manage because a lot of jokage of the media and plantations. These are the common problems in the systems.
Okay.
So maintaining of the system is a very difficult and very essential thing.
Okay. Now, MBR, regarding MBR, as far as I remember, we were discussing at one point of time, you need a specific height above the STP to remove your membranes. So what is the approximate height required above the top of the STP to remove the membranes?
Minimum 2 meters.
So you need additional height as well, right?
Yeah. In either case, in MBBR also you need a minimum 2 meters above the tank if it is underground to walk the person to maintain the system above the tank.
Okay. Okay. Now, final question from my side. Now, we agree any kind of treatment, especially MBBR, MBR, and other SBR. Now, what are you guys doing about the left sludge?
See, in all the systems, this sludge is treated through a centrifuge. The device was sludge dewatering. We are using centrifuge. In the centrifuge, we are dewatering the sludge, and the dried sludge can be used as a manure, and water which comes out can again go back to the collection tank.
Okay, thank you. I'm done. Chintan, your mic is muted, Chintan.
Thank you. Happens with me also.
That's the expert.
Sometimes even I forget. So we have a question from Mr. Pragnesh Makwana also. Pragnesh, please go ahead.
Okay, thank you, Chintan. पुरुषोत्तम जी 4-5 सवाल है, एक सवाल नहीं है. I have jotted it down. पहला सवाल ये था कि हम दया जी भी मेरे ख्याल से एग्री करते हैं कि when we think about the soak pits में do we recommend brick bats?
No. No, brick bed absorbs water once only. You need to fill it with big boulders. I never do with the brick bed, and there should not be any construction around this pit.
That's so. What is your opinion, Purushottam ji?
Absolutely correct, sir.
Okay.
The purpose of soak pit is to soak the water on continuous basis and for the longer period.
Okay. So brick
Wherein,
beds are
wherein Pragnesh, brick bed soaks water once in its lifetime. And
Correct.
secondly, the kind of bricks available here, they may become the mud or soil after
disintegrate.
few years.
Disintegrate.
Yeah.
Yeah. Second thing was that when we think about all those natural treatments, the bio treatments, we are. You had mentioned that we can use it for all the gardening purpose and all those secondary uses. But I was not able to see any kind of treatment wherein we can kill the bacterias and then we can use it. So what is your opinion about using it for all the secondary usages, but then those secondary usages might be having some kind of contacts coming down with water of the treated water in the human contact. So what
See,
is your opinion about those particular things?
see, treated water in all these natural technologies, we can always put a chlorine and or in that so that we can easily use it for the other all the utility purposes. For disinfection, we can always use a chlorine.
So we have to have the disinfection process done over there
Yes.
before we end up in the secondary use, whatever the secondary use.
For in the final tank so that we can use it.
Okay. Then the next one was that out of this n number of systems, which do you recommend that in your terms, what would be the most economical system, and what would be the normal costing of any treatment?
See, sir, it depends on the locality and the area. First of all, if you are asking me what to recommend in Bombay, I always recommend for the MBBR system because cost भी कम है, operation maintenance भी कम है, and
Okay.
आपको एरिया भी कम लगने वाला है. Whereas आपके पास अगर कोई प्रोजेक्ट आपका आउट ऑफ बॉम्बे है या फिर बहुत सारी जगह है आपके पास, then go for the natural systems where there is no power required. पावर की इशू भी होती है आउट ऑफ
Correct.
बॉम्बे. We
Correct.
can use the
Correct.
natural systems.
Okay. And approximately what are the treatment cost per liter or per m cube?
See, for MBPR, the per meter cube cost is approximately 15 to 20 rupees
Per m cube.
for MBBR system.
Okay, that's too much cost. That's too low. That's very cheap, I suppose.
Yeah, whereas as MBR technology, the approximate cost is 50 to 60 rupees per meter cube is treatment cost.
Okay.
That is mainly because of replacement cost of the membranes.
Membranes.
And they are imported. I think nobody manufactures membranes in India. Am I right, Mr. Purshottam?
Yes, now started. Some companies started, but they're not still on their fully occupied and fully tried.
So 20 to 30 rupees, we can say we can have the treatment done from approximately 20 to 30 rupees per m cube to 50 rupees, 50 to 50, 60 rupees per m cube.
Yes.
Depending upon what type of treatment we do.
Yes.
The ranges from 20 rupees to 60 rupees.
See, in that case also, if we are going for the smaller plant, like 50 KLD plant, that is not viable because volume is very less. If you go for the 1 MLD plant, it is very much viable, even if it may go for 10 rupees also per meter cube because flow is high, volume is high.
Correct. Okay. The last one, the volume what we told, what you just discussed, that the minimum quantity of something about 20%, 30% in the MBBR is required to have the system going into a very efficient working.
Yes.
So what are the criteria for other systems also? The minimum quantum required to start up the system for efficiency.
See, in natural processes, it is not required because we are not doing oxidation there through aeration.
Okay.
It's natural aeration.
Correct.
Whereas the MBR, MBBR, SAF system, SBR, we need at least 25 to 30% load because we are giving a aeration through air blowers and giving oxidization through a mechanical system through air blowers. Whereas other systems are natural. There is natural aeration is there. So there is no load restrictions there.
Okay, in that case, if, what would be the remedial measures if at all we have got an STP which is having that kind of system installed, MBR or MBBR, whatever the case may be, and the project has been just started for occupation and people are coming in to occupy the premises, but the premises are not fully occupied to come down to that ratio of 20% or 25%. And what are the remedial measure?
What we do during the initial designing, but we always give a bypass system through inlet, so that by the time the load comes, we can bypass the system because it's an emergency. We cannot run the plant. And second thing, if what we do nowadays is, if say the plant is 200 KL capacity for the complete project, we do 2 compartments in the MBBR and settling tank, so that your load, minimum load required now is 20, not 25, it is now 10%, 15%, because we divided the aeration tank in 2 parts and settling in 2 parts. When 30% load comes, the plant runs through only one part, one section, one part of the MBBR tank and settling tank, and after full load you can run on the both the part you can start and run.
Okay. So we divide the entire plant into some parts.
Not entire plant, only MBBR aeration tank and settling tank.
Yeah. Wherein the actual treatment has to be done.
Yes.
Okay.
Actual biological treatment.
Now, just on the subject which you told that we have to provide an overflow arrangement or a bypass arrangement, not overflow, sorry, bypass arrangement. So, what are the remedial measures which we are supposed to take when the plant is under maintenance and we are not able to treat anything? So, is the law permitting us to dispose our sewage without any kind of treatment to the municipal sewers?
Pragnesh, it is mandatory. I have done some STPs in Mumbai where Mr. Purshottam was part of it. Corporation always says you have to have the bypass to the street connection. So in case if at all say there's something wrong with the STP or it needs maintenance, you need to dispose it off, and you cannot have the soak pits or soak pit in that case. So it is mandatory to have the bypass for it. Right?
Now,
I think his question here is that in case we are having a bypass situation where the STP is under maintenance, is it permissible to discharge the sewage without treatment? I think that's what his question is.
It is permitted.
My point is different. My point is, in STPs, all the pumps are standby, air blower is standby. So there are very rare chances of the complete failure of the system.
Okay.
All the pumps are standby. One working on standby.
And I'm just taking an hypothetical. I'm just taking a hypothetical situation wherein something is gone wrong and the STPs are not functioning. So in that case, yes, we have. But what is the again one more question in the same scenario, that if at all we do not have a municipal sewer connected, it's a remote area and we have got an STP and STP has gone under maintenance.
Yes.
So in that case, what is to be done? Because then we don't have any kind of bypass arrangement also.
You are right. We are also facing this problem. But then in that case, the last option is we have to bring the tankers and deposit off. Municipal tankers for sewage disposal, all the tankers and take it out.
Okay. Is it possible that the first collection tank which we have might be the capacity of the collection tank? We can have it in such a way that we are able to collect the sewage for something 1 day or 2 days or 3 days, something like that.
Not possible, sir. Not possible. Impossible.
Or part of it.
Not possible. See,
no, not possible.
And now I'm designing the STP. I'm taking 8 hours retention for collection tank.
Okay.
अभी लोग कभी पूछते तो 8 घंटा 8 घंटा क्यों ले रहा है, 6 घंटा क्यों ले रहा है, 4 घंटा क्यों ले रहा है.
Oh, okay.
तो भूल जाओ.
Other way around. Okay.
Space is the problem.
Okay. Yeah, thank you very much. Chintan, I'm done. Thank you very much, sir.
Okay, yeah. The next set of questions I believe is coming from Mr. Bhushan Shah. Mr. Bhushan Shah, please go ahead with your questions.
I would, Chintan, in that case, I would request
Uh,
the person who asked the question to first of all self-introduce himself, because
yes,
I'm
yes,
seeing Bhushan Shah many a times in our webinars, and he's quite punctual. Then I
right,
realized that he is from the MLP. But then
right.
it's better you tell them to self-introduce themselves.
Sure, sure. Please introduce yourself,
Sir,
Mr. Bhushan.
please.
Right, yeah.
Yeah, sir, my name is Bhushan Shah. I am basically a civil engineer. I have my chemical factories at Ambernath MIDC zone, and I have constructed so many pharmaceutical factories also. And there I have come across a very big problem of treating this chemical polluted waters of dyes and chemical factories. They generate lot of big waters of colored solutions, or maybe washing the vessels or treatments or plants, and generating lot of waste of water. Nowadays, government has fixed a water meter for producing their wastewater and counting their wastewater, accumulating their number of liters in their counting. So, what do you suggest for such kind of factories and pharmaceutical factories or chemical factories?
Sir, all these factories are coming under the MPCB, Maharashtra Pollution Control Code. So it is mandatory for them to put a effluent treatment plant, and they have to treat the water and make it disposable. Then only they can dispose it off. As per
Yeah,
MPCB,
but sometimes it is not possible to tell the 100% water, give 100% water to the MPCB. We should treat some water. See the number of what do you say, material what we produce during the turnover of the monthly turnover. We may not show it officially. We may not send them official letters. So sometimes these quantities may vary. In that case, what should be done?
no. See, in any case, you are not allowed to put this water outside without treated. It is a chemical.
See, in chemical fine. See, now in Gujarat, Baroda, Ahmedabad, Vapi, Valsad, there are a lot of chemical factories. I know a lot of friends who have such kind of factories, ink factories. So now they produce such a lot of wastewater, and there is no such plant there.
That is the problem. That is the reason all this area of Ankleshwar and Vapi is so polluted.
Yeah.
I would like to add one thing. Sir, ignorance of the law is not an excuse.
Absolutely.
Not allowed.
See, there are CPCB norms, there are CPCB parameters set down for most of the industries. And as Pragnesh Bhai rightly said, being ignorant towards the norms and
Then
not following
I am not
like,
asking him to be ignorant. I just wanted to be what treatment can be done prior to sending them to pollution control or CPCB or whatever controlling authority, so that the number of liters can be controlled over there.
Mr. Bhushan, I will interrupt here. See, every factory disposes different kind of chemical. Am I right? So, Mr.
Yes.
Purshottam, and also, correct me if I'm wrong. So, every discharged effluent needs different treatment. You cannot have uniform policy for that. So, for that, you need to have some specialized person like Mr. Purshottam who can, collect your disposed sewage and get it tasted and suggest a treatment according to what you are disposing.
In last 15, 18 years, I have dealt across all the type of plants like textiles, chemicals, dairies, distilleries. Every effluent is a different character, different treatment, different solution. Say, if you go for dairy, you have to go for anaerobic treatment by default, anaerobic followed by aerobic. In textile, there is different. In distilleries, anaerobic is followed by aerobic because very high COD and BOD. So every effluent is different. It has to be treated according to the parameters and the character.
Thank you, sir. Thank you.
right. Do we have any further questions?
I
Otherwise,
don't have a question, but I have one demand from Purshottam ji, and I
Yes.
hope he will fulfill. Now,
Yes.
this was Purshottam. I know that this was one part of your knowledge. Second part is the solid waste management.
Yes, sir.
And water purification. We had debate one day. Some schools are, putting in their brochures, we are giving RO water to your kids.
Yes.
So I would appreciate if I'll ask Chintan and Pragnesh to talk to each other, and maybe we can have one more webinar on these two subjects: one, solid waste management, and what should be the ideal potable water, like in Ankleshwar. In Ankleshwar, my sister is having RO purifier. So this is also very a technical subject. So I'll ask Chintan and Pragnesh to talk to each other and have one more webinar on this.
Sure, sir, we can do that.
Yeah. If Mr. Purshottam permits.
He will.
My pleasure. Always ready to do that. My pleasure.
Thank you very much, sir. We will definitely coordinate about this particular thing.
Yes, sir.
Pleasure.
I have one question today. So my question, Purshottam ji, is when we started, we spoke about septic tank, which is an anaerobic process, and then we moved on to certain different plants which were aerobic in nature, which needed aeration to be provided. So what is it's more like a laymannish question, I would say, but what is the right method? Which is the more optimum process? Is an anaerobic process better or an aerobic process? And why do STPs generally rely on an aerobic process? Why can't it be anaerobic?
Good question. Very good question. First of all, you have to understand what is the COD and BOD in STP. BOD is 300, COD is 600. In that case, where COD is less, COD indicates you whether you need an anaerobic treatment or not.
Okay.
Anaerobic treatment is, what is anaerobic? Absence of oxygen.
Absolutely.
Anaerobic is presence of oxygen. Simple. If you go for distilleries, COD is 1 lakh.
Okay.
Then you put an anaerobic treatment, bring it back to 30,000, and methane gas which develops, they use for the boilers. Correct? In that case, anaerobic is very good process for them. Whereas in sewage, COD BOD content is not high, so anaerobic not recommended. Whereas in septic tank, the anaerobic is given only to since they don't have to give any mechanical system. That is the reason they are providing only anaerobic. Whereas septic tank treatment is not a complete treatment; it's only primary treatment. So pollutants, COD, BOD content is important to select whether anaerobic required or not.
Okay. Okay. So, do we have any further questions? Do I see any questions, or is it a time for wrap up? Okay, there are no further questions, I think. So,
sorry to interrupt, Chintan. There's one Mr. Ashish who has turned his video on.
Oh, okay. I can't see that.
Yeah.
Okay, Mr. Ashish, if you have a question, please feel free to unmute and ask it.
Please.
Yeah, hello everyone. I'm new to this webinar. I've contacted Mr. Chintan, so I'm new to this field. So I'm only in a listening mode right now. So once I go through deep in topic, I'll definitely have more questions.
Ashish, first of all, you introduce yourself.
I'm into Army. I'm an officer in Army. I'm Major Chandra Prakash.
Great.
So I got interested in this field. So I searched in internet. So I got in contact with Mr. Chintan. He gave me the link. So in that way, I'm into this webinar.
Thank you.
Great. Thank you.
Right. So this major from the Indian Army, he is more interested in understanding water conservation and water recycling because he thinks, of course, he thinks, and we all endorse that is going to be the future eventually. So while he supports us by fighting the wrong elements at the border as well, he's also going to very soon in the future fight the water battle that we are going to have. So welcome, sir. think eventually there are no further questions, so I think we'll.
Let
Yeah.
let Mr. Ashish know that we conduct webinars on every Saturday at 4 o'clock. You can be in touch, or if you can share your number, we will add you in tech savvy
I,
group.
I am in touch with him and I am forwarding the details.
Thank you.
Right. So this has been a wonderful session today. I believe we have one more video come up. We have Mr. Girish Panchal, who's also a very prominent consultant in the country. Okay, he turned off his video. Girish Uncle, do you have a question?
Girish uncle, your mic is on. You unmute your mic, please.
Hi, good evening, everybody.
Good evening.
Thank you for taking us across the various processes for water treatment. I have been operating a plant, and the construction water was generated out of this. The almost, I think, 80% water was used for construction in Powai. So it was basically with SAP system. And just for a major, I'm ex-Indian Navy. Retired in '94, and since then I'm in construction industry with various posts. And now I'm, as Chintan has just introduced, I'm as a consultant now, and doing a lot of projects as far as the MEP is concerned. So entire plumbing, firefighting, air conditioning, ventilation, electrical, we do consulting for all the projects. Okay, Purshottam ji, just coming to the subject. Which is the system which has got the best COD and BOD at the fag end of the treatment without the polishing?
Mbps.
Yeah.
Membrane bioreactor.
Okay.
No doubt.
And which is the best system as far as the solid waste generated for disposal?
Solid waste in terms of what, sewage or solid garbage?
Disposal from the plant.
Pardon?
Disposal from the plant, solid waste disposal.
Yeah.
As far as sludge is concerned, which is the plant which is the best as far as the minimum sludge generated?
See, in my opinion, sludge is more or less the same to every plant, more or less same. The reason is, if you are removing the complete COD BOD, then you have to remove the sludge. Otherwise, COD BOD cannot be achieved.
Very true.
You have to remove the sludge periodically. That is essential. Otherwise, plant result will not be as good as we required. So sludge quantity is more or less same to every plant, especially this SAF, MBBR, MBR, all these plants.
Okay. I think Pragnesh had few questions about the maintenance of the plant. In my entire lifespan, almost constantly around 8 to 10 years, I have been operating the plants also. For his advantage, I can just clarify with the, I think in case Chintan is okay with it.
Absolutely.
Okay. Basically, what happens is when you are operating a plant and due to any error, in case if there is any issue with the plant, generally, as I think Daya Sahab has also confirmed it, every plant has got a certain amount of a municipal bypass which is given. Now that can be used in emergency, but it cannot be used as a consistent process. The second is, in case if a disposal, in case of emergency, it has to be done. It has to be done with the primary treatment, and tertiary treatment can go for a maintenance. So that is the another way of doing it. Secondly, as I think Purshottam ji has already said, that retention time is around 8 hours. Originally, we used to do around 6 to 8 hours. And now I think even there are plants where the retention time or initial cycle time is taken considered as a 12 hours. So that gives the little buffer as far as the maintenance are concerned. And generally maintenance is in the tertiary treatment or the polishing agent at the play. Secondly, as far as usage of the water, you were saying, when the process is completed and after polishing, that is after carbon filter, scent filter and a carbon filter, again a dosing of a chlorine is done. At the fag end, you have to have a free chlorine. Till such time you have a free chlorine, a personal contact of water for any secondary use is okay. It can be used for gardening also, it can be used for construction, it can be used for flushing, and to an extent, even it can be used in a water bodies.
Don't give him.
I'm done.
Okay.
I
Chintan,
have one suggestion to make. The most of the failures of the STPs in residential buildings is due to lack of knowledge of operators. In that case, I would suggest everybody who is recommending STP should have the AMC with the installer. Like maybe in some cases, Mr. Purshottam. एक साल तक वो बंदा सीखेगा from his technician or maybe his engineer. Then that guy, any layman can operate STP, I think. What's your take on that, Purshottam ji?
See, my observations is even if you give a 1 year training, after that you operate operation to a layman, what building people will do? This is what I have seen. They tell watchmen to operate the plant.
Yeah.
Or any person who is having doing lot of 10 other works, he gives works to operate the STPs, which is not actually correct. Which will spoil the STP, completely spoil the STP. So, in my opinion, a dedicated person is required, whether it's from my side or their side.
I agree.
There has to be a professional team operating the plant. Otherwise, plant cannot run efficiently. The distribution system will have a malfunctioning. You will have an hygienic issues also. There are number of societies where these problems are come, and ultimately, to an extent, societies have requested BMC for a complete drainage system to connect it from the bypass, and they have stopped the plant.
Yeah,
So,
wonderful insight.
at the moment, I think this has been practiced for last few years, that basic AMC and the operating contract is given to the installer, the STP manufacturer, for minimum period of 5 years. And all SRA project, it is made compulsory for 10 years.
Yes,
Great.
Right.
But
I think that
is required.
the way to go with the survival. As far as the plant and equipments are concerned, it is not layman's job. There has to be a professional team operating. As far as operating costs are concerned, cost of chemical, society has to take that load and reuse, because they have to be explained basically that even for the secondary use, the amount of water which they are using it and what they are paying as far as STP is concerned, much cheaper than buying tanker water from the local place.
Absolutely. Yeah, thank you very much.
Chintan,
I think
time
Mr.
permits.
Pragnesh Makwana has something to add or ask. Pragnesh,
If
go
time
ahead.
permits, if time permits.
Yeah, sure. We don't have any hall to empty.
Okay. There was one small query that many a times what happens is that might be when we are treating the water and using it for the secondary use, we are left up with much surplus of water. So that surplus of water either goes down the drains again to the municipal sewers, or might be we have to dispose it off to some tankers or something like that. So what is the solution to that particular surplus of water which is left off? Because then we cannot say that I will be treating only this much of water and rest I will be just draining into the drains. Ultimately, what happens is that after treatment also we have to drain it into the municipal sewers itself.
Right.
So what is what are your comments on it?
These problems come especially in rainy season, where the garden water requirement will be reduced to minimum. So there is no other way to then put it to the municipal sewer line.
Okay. That is the only way. Second thing.
Otherwise, there is no point to call tankers and give it to them.
Okay. Then second thing was that, yeah.
Pragnesh, I can suggest something. Most of the places in the residential complex, they have the commercial nearby. You can sell that water to commercial units.
बढ़िया
मैं उसी पे आ रहा था.
Which we have done it in Powai, and lakhs of liter of water we used to supply them at nominal cost, which was much cheaper than the municipal as far as the commercial buildings are concerned, because their cost is very high. Deepak, they knows very well on that.
Okay, but then again, if at all we store it and give it to somebody else, I'm given to understand that the water might go septic over a period of something about 48 hours or 24 hours. So what are your comments on that particular thing?
That you have to maintain free chlorine. That's the
No, but
only
then
way.
even
Only.
no, but then we cannot maintain the see the residual chlorine what we are talking about. If at all it is too high,
Yes.
then it is might be we end up ending up without any kind of proper use for that, because that content of chlorine might not be suitable for the end use what we are talking about.
See, there is no secondary use which cannot take the load of free chlorine.
No, for
Purushottam ji.
gardening, no, if at all we talk about gardening, obviously some chlorine content beyond the capacity, beyond that particular thing, would be affecting the natural flora and fauna.
No, see, doesn't happen because once it comes to a fagant as far as the release of water in the garden is concerned, in a contact of atmosphere, the chlorine will give away.
Yes.
Will
No, but
disappear.
but the thing is what you know, what I'm asking you is that if at all we are storing it beyond a certain period,
Yeah.
then that chlorine is always there till such period.
Yes. So
So
there has to be a cycle of operation. You cannot store it for days together.
the simple I can give you the simple example the other way around, that if at all we are using for flushing purposes,
Yeah.
okay, and I am using a flush tank,
Yes.
and I have gone out station for a tour, and that water is
Okay.
stored in the flush tank,
Okay.
then what is the scenario?
In that case, the people in the society have to be educated that
Yeah,
at the time when
yeah. They do
going
not
out,
have to store the water in the flush tank.
yeah, they have to flush it and shut off the cork so
Okay,
that there is no stagnant water in the flushing tank.
what is your opinion, Mr. Purushottam? What are your comments on this?
It's correct
Yeah,
because
as a special
it's a
company.
sewage water. It's a hungry water. It's a treated water. So it gets again bacterial growth very quickly after some time. So it is better that either you flush it, if you flushing the water in the flushing tank is there for more than 2 days, 3 days, 4 days. After coming back, either you flush it for first time, second time. After that, it will get clear. Otherwise, you can stop the cork as Pankaj have said, so that there is no water in the flushing tank.
Can I add something here?
Yeah, go ahead.
Pragnesh bhai, I've been part of code committees for certain countries for their grey water recycling and black water recycling. One of them is, of course, Singapore. Their draft code has been sent to me, and I was in the committee. So there they have specifically, of course, Singapore is a very different country. It's like living in a boarding school where they have very strict rules. But there they have specifically mentioned the duration of water that can be stored, what kind of treatment, what kind of treatment gray water has undergone. So there are different parameters, what kind of treatment or recycling the black water has undergone, especially when we talk about new water, and how long can you store it, and within how much period you have to dispose it of. So these are the parameters which have already been provided in some of the codes. I'm sure, yes, in our country we are lacking behind when it comes to gray water. I'm not sure Purushottamji will be the right person to tell about this, but I do not know, do we still have any strong codes which, give us these parameters where storage of these kind of treated water or recycled waters is specified?
We still don't have that
There are
kind
no
of
such.
codes for that.
Absolutely. So you'll probably have to look up at some international codes and find out case to case that what is the amount of time that you could probably store this kind of water, or in how much time you have to dispose it of. I think that's the only solution we can think of right now.
If the parameters are not there, might be the vendor or the person like Mr. Purushottam, they can come out that whenever we install a certain kind of STP, might be
Absolutely.
they will recommend, okay, this type of STP you cannot store it beyond this period. That's it.
Absolutely. And especially,
It has to be followed. It has to be followed strictly.
absolutely. It depends on the kind of treatment and the kind of residual disinfectant that you're using in the water. I think it more depends on that rather than the kind of treatment process it is going through.
Correct. That is also there.
And most of the time, it is not in our hands. No, the overhead tank capacity. What is overhead tank capacity? What is flushing tank capacity? That also matters.
Absolutely. Absolutely. So there are variables and lots of parameters involved. So
It has to
yeah,
have a.
I think this discussion could actually go on for a day's time, actually, at least. But I think it's been a wonderful session today, and quite interactive at the most, I should say. And before we end the session, of course, it's mandatory to have a vote of thanks. And may I request Pragnesh Bhai to please offer the vote of thanks for today's session?
Thank you, Chintan. That was a wonderful session. A huge thanks to Mr. Purshottam. That was an eye-opening type of thing about the various treatment methods which we are able to use for recycling of wastewater. Specifically, when we think about the natural ways to treat it, obviously in the remote areas where might be nowadays we have got this campuses coming on, university campuses coming on, so there might be when there's no space constraint, we can go in for those natural ways of treatment. And of course for the modern ways in the cities like Mumbai, metros like Mumbai, that we can use the mechanical ways of treatment. Definitely, it was a very good session, sir. I am very much thankful to you for such a kind session, and I'm also taking a promise from you that we will be having similar kind of session for water treatments and
And solid
solid
waste
waste
management. And solid
and
waste
solid
management.
and solid waste management and so. I also like to thank all the participants who have come down over here to grab this opportunity and learn something about the wastewater recycling treatments, which Mr. Purushottam has explained today. Thank you very much, sir. Chintan, back to you.
Yeah, actually, there's one more hand being raised, and this is from a very interesting person. So I'll make this exception. This hand has been raised by Adnan Leri, who actually suggested that this session be conducted on recycling. So this is one exception I will take with everybody's permission. I know we already had the vote of thanks, but I request that we take this. This could be interesting.
Thank you.
Actually, I was
Yes,
just
Adnan.
thinking about why I wasn't able to comment or put something on the chat, but I think you've switched that functionality off.
Yes, it is.
I,
We want people to talk.
okay, so my entire so me and my family have thought about starting up an entire process of integrating the entire waste and producing energy, water. I mean, mostly we want water more than energy. So I mean, I just wanted your contact. I wanted to type in and ask you your email ID. So that's why I just raised my hand. Nothing else.
His total detail will be पुरुषोत्तम जी आप अपना एक प्रोफाइल ग्रुप में डाल दीजिए. Then
He's
you will
right
get it.
there on Tech Savvy.
Yeah. Okay. That's great. That's
He's not
great.
tech savvy.
Okay. Okay. Thank you. Thank you. That's it.
Right. So great. So this has been, as I said earlier, this has been a wonderful session. Thank you everybody for joining in. Of course, this video will be available on YouTube in a few moments from now. Till then, we'll meet again next Saturday with one more wonderful session. Till then, everybody stay safe, take care, and goodbye.
Yeah. Goodbye, everybody.
Thank
Bye.
you. Thank you.
Yeah. Bye. Take care.
Thank you.
Thank you.